History is often written in the names of kings and conquerors, but the true foundations of our modern world were laid by a scholar from the East. To understand the digital age, the satellites in our orbit, and the architecture of our cities, we must travel back 12 centuries to the golden heart of Mesopotamia. This is the story of Muhammad ibn Musa al-Khwarizmi, a man whose mind became the bridge between ancient wisdom and the future of humanity. Born around 780 AD in the region of Khwarizma, vibrant crossroads of cultures in modern-day Uzbekistan, al-Khwarizmi's early life is shrouded in the mists of time. However, his destiny was tied to the greatest intellectual movement of the Middle Ages. He was summoned to Baghdad, the city of peace, which was then the capital of the Abbasid Caliphate and the center of the known world's brainpower. Under Caliph Oldman, Baghdad became a sanctuary for scholars. The Caliph established the Bayt al-Hikmah, or the House of Wisdom. Al-Khwarizmi was not just a member, he was its heartbeat. As the director of this prestigious institution, he oversaw the translation of thousands of manuscripts from Greek, Sanskrit, and Persian into Arabic. But al-Khwarizmi was not a mere librarian of the past. He was a synthesizer. He took the scattered fragments of global knowledge and forged them into a unified logical system that the world had never seen before. The first great pillar of his legacy is the revolution of numbers. Before al-Khwarizmi, the Western world was trapped in the cumbersome system of Roman numerals. Imagine trying to perform complex division or long-term financial forecasting using letters like X, L, C, and M. It was a system that stifled progress. Al-Khwarizmi authored a groundbreaking work titled Kitb al-Jamwa al-Tafa, Kbe, or the Book of Addition and Subtraction, according to the Hindu calculation. In this masterpiece, he introduced the Hindu-Arabic numeral system to the Islamic world, and, eventually, to the Latin West. He meticulously explained the base-10 positional system, the idea that the value of a digit depends on its place. But his most profound contribution here was the formalization of the zero, or cipher. While the concept had roots in India, al-Khwarizmi was the one who defined its functional role in arithmetic. He showed that zero was not just nothing. It was a mathematical placeholder that allowed for the creation of infinite values with only 10 symbols. This book was so influential that when it reached Europe centuries later, his name was Latinized as algorithm. The very word algorithm, which governs every social media feed and every AI today, is a permanent linguistic monument to his name. In the year 820 AD, al-Khwarizmi published the book that would earn him the title, the father of Algebra. The title was Al-Kitab al-Mukhtasar fi Hisab Al-Jabr wal-Muqabala. To the international audience, this is often shortened to Algebra, but the full title reveals a sophisticated dual process of logic. Let us analyze the truth of his methodology. Without simplification, algebra means restoration, or completion. It is the process of removing a negative term from one side of an equation and adding it to the other, to make the expression positive and whole. Al-Muqabala means balancing, or opposition. It is the act of cancelling out equal terms from both sides of the equation, to simplify the problem to its core essence. Al-Khwarizmi's genius was in creating a general theory for solving equations. He identified 6 standard types of quadratic and linear equations. He did not use modern symbolic notation, but used a rich, descriptive vocabulary. He called the unknown variable shay, or the thing, and the square of that variable mal, or wealth. Most importantly, he provided geometric proofs. He recognized that for a mathematical truth to be absolute, it must be demonstrable in physical space. To solve a quadratic equation, he would draw a literal square and add rectangles to its sides. This was the birth of analytical geometry. He turned abstract problems into visual certainties, providing a toolkit for engineers and merchants alike. Al-Khwarizmi's eyes were not only fixed on the ledger, they were turned toward the stars. Astronomy in the 9th century was the high-tech frontier of science, essential for navigation and timekeeping. His work, Zij al-Sintain, was a massive compilation based on Indian, Persian, and Greek sources. This book contained 116 tables of calendrical and astronomical data. He provided the movements of the sun, the moon, and the 5 known planets. His calculations allowed scholars to predict eclipses with unprecedented accuracy. He also refined the use of the astrolabe, a complex mechanical device used to determine latitude. He wrote specific manuals on its construction and use. These works were the GPS manuals of the medieval world, ensuring that travelers never lost their way. In the field of geography, al-Khwarizmi was a pioneer who moved beyond the classical errors of the past. His book, Kitab, Surat al-Ard, or The Image of the Earth, was completed in 833 AD. While it was inspired by Ptolemy, al-Khwarizmi did not merely copy him, he corrected him. Working with a team of 70 geographers, he oversaw the creation of the first world map of the Muslim era. He corrected the gross overestimation of the length of the Mediterranean Sea. He provided the exact coordinates of 2,402 locations, including cities, mountains, and rivers. He organized the world into 7 climates, a precursor to our modern climate zones. His map included parts of the Atlantic and Indian Oceans that were previously unknown. He effectively transformed geography from travelers' tales into a rigorous, data-driven science. Al-Khwarizmi was also a man of action and empirical observation. One fascinating episode was a diplomatic and scientific mission ordered by Caliph al-Wathiq. The Caliph was intrigued by the account of the Ashabul Coffee, or the 7 sleepers. Al-Khwarizmi did not approach this as a theologian, but as a scientist. He traveled to the site, scaled the mountains, and personally examined the remains. He reported back that the preservation of the bodies was the result of skilled human intervention. He identified the use of balsam, camphor, and specialized burial techniques used to mummify the dead. This mission perfectly encapsulates his philosophy. Faith and reason are not enemies. It showed that reason is the tool we use to understand the wonders of the world. Perhaps his most ambitious project was the measurement of the Earth itself. Caliph Olman wanted to know the exact circumference of our planet. To achieve this, al-Khwarizmi led to teams of scientists into the Sinjar Desert. Their method was ingenious. One team walked north and the other south. They measured the distance required for the elevation of the pole star to change by exactly 1 degree. Using this data, al-Khwarizmi calculated the Earth's circumference with stunning precision. This was a feat of pure mathematics and observational stamina. It proved that the scholars of Baghdad were measurers of reality. Muhammad ibn Musa al-Khwarizmi passed away around 850 AD, but his mind never died. When the Latin world began to awaken in the 12th century, it was his books that they reached for first. Scholars like Adelard of Bath and Robert of Chester dedicated their lives to translating his manuscripts into Latin. Without his Al-Jabr, the Renaissance would have lacked the tools for the scientific revolution. Without his algorithms, the Enlightenment would have lacked the logic for the Industrial Age. As historian Anthony Nutting stated, al-Khwarizmi was the bridge. Today, his name is spoken every time a computer processes data. Every time a student solves for X, he is there. Every time a pilot checks their coordinates, they use his legacy. He remains the quiet architect of our logical universe, a man from Khwarizm who taught us that the world is a beautiful, balanced equation, waiting to be solved.